Assalamualaikum and hello everyone. Today, our group will be presenting on the topic entropy in thermodynamics. In this presentation, we will explain what entropy is, its physical meaning, the second law of thermodynamics, and its application in real-life system.
So, what is entropy? Entropy is a measure of how spread out energy is in a system. When energy is concentrated in one place, the entropy is low. As the energy becomes more spread out throughout the system, the entropy increases. The entropy is represented by the symbol S, and its unit is joules per Kelvin, which shows that the entropy is related to both energy and temperature. On the right side of the slide, we can see that the change in entropy from solid to liquid and then liquid to the gas. A solid has the least randomness and therefore the lowest entropy. When it changes into liquid, the particles become more free to move, so the entropy increases. In the gas state, the particles are highly spread out and move randomly, which results in the highest entropy. This shows that as randomness increases, entropy also increases. Next, physical meaning of entropy can be compared by ordered and disordered systems. An ordered system, where particles are arranged in a regular patterns, has low entropy. This can be seen in a diagram showing particles closely packed together. As the system becomes more disordered, the particles are arranged more randomly and the entropy increases. This is shown by the scattered particle arrangement, which represented a high entropy state. In real life, most physical processes are irreversible. For example, once a system becomes disordered, it does not naturally return to a more ordered state without external work. Therefore, entropy helps us understand why natural processes move in one direction only. It is from lower entropy to higher entropy. Next, my groupmate will explain about the mathematical definition of entropy and the second law of thermodynamics.
This equation shows how entropy changes when heat is transferred. Delta S is the change in entropy, Q is the heat added or removed, and T is the temperature in Kelvin. This formula is only used when the temperature stays constant and the process is reversible. If heat enters the system, entropy increases. If heat leaves the system, entropy decreases. The second law of thermodynamics explains the direction of natural processes. It tells us that energy does not move randomly. In any natural process, the total entropy of the universe will always increase or stay the same. It can never decrease. This is why heat always flows from a hot object to a cold object, not the other way around. To move heat from cold to hot, we must do work like in a refrigerator or air conditioner. Because of this law, no heat engine can be 100% efficient. Some energy is always lost and become less useful due to entropy increase. Entropy in common process. Number 1, heat transfer. Number 2, gas expansion. And number 3, phase change. Heat transfer is the movement of heat from a high temperature object to a low temperature object. This happens naturally because of the second law of thermodynamics. When heat is transferred, entropy increase. For example, when a hot object is placed in a cool room, heat flows to the surroundings until the temperatures become equal. Number 2, gas expansion. Gas expansion happens when a gas increases in volume. When a gas expands, the gas molecules have more space to move. This increases disorder, so entropy increases. Gas expansion is commonly used in engines and turbines to produce work. Number 3, phase change. Phase change happens when a substance changes its state, such as from a solid to liquid or liquid to gas. During phase change, energy is absorbed or released without a change in temperature. The molecules become more spread out, so entropy increases. For example, when ice melts into water, entropy increases because the molecules are less ordered.
Next, we will move to the applications. The first is heat engine. A heat engine takes heat from a hot source and converts part of it into work. The remaining heat is released to a cold source. A heat engine cannot be 100% efficient because of entropy increase. And the second is refrigerator and air conditioner. A refrigerator removes heat from a cold space and releases it to the surroundings using external work. The decrease in entropy inside a refrigerator is compensated by a larger increase in entropy of the surroundings. And finally, we have come to the conclusions. There are three conclusions that we got here. The first is entropy is a fundamental concept that measures disorder and energy dispersion in a system. Second, it explains the direction of natural process and is governed by the second law of thermodynamics, which state that the total entropy of an isolated system never decreases. And finally, entropy is also essential in understanding real-world applications such as refrigeration and air conditioning systems, where energy transfer occurs in a controlled but irreversible manner. Okay, that's all from us. Thank you.